One of the important things is knowing where to start. Lawrence Corley is very big on critical path, and any uh, management project that requires a great deal of people usually is going to have a critical path worked out. Here, we're driven by a schedule of people arriving week after week, and so we need to be ready for them. The initial objective here is to get the load bearing walls up. But sometimes getting those up is going to require flooring a mezzanine or stage area or mechanical room. So in this particular plan here, there's a mechanical room over the stage back in the back of the church here. There's a mezzanine here in the middle of the church. And then there's a storage area over this hallway. And this is in the original design here. So what that means is that for them to set trusses, you're going to have to get some of these platforms built. The mezzanine here is not in the load bearing directly, but let's take a quick look at that. If we look at the different areas, the one behind the stage area or above the stage area here, we've looked at it earlier. It's broken up into a platform, and the lower walls supports this structure here, and then there's an upper wall. So we've got to get this floor built before we could build the upper wall to get it to the correct height of 20 feet 4 inches. So that means this has to be started pretty quickly. The underneath walls and then this flooring, because it's you can't go on up to the full truss height until you have the floor in. So that's the issue with platform framing. You have to build a platform. If we come down here and look at the mezzanine, and let's expand it here a little bit. If we look at the edge of this here, they've actually showing platform framing here on the outside edge. And this is in a load-bearing 20-foot wall here, shear wall type J. It's interesting. So they got platform framing here just for this outer edge. None of the rest of it matters here as far as the load bearing. So what if you built it exactly like this, then you could not build the 20-foot wall until you had actually built this platform here. So that would necessitate a certain amount of flooring and plywood. So I suggested that we go back to a ledger here, remove the platform aspect on this very outer edge, and just go to a ledger with hangers. And so that got approved rather quickly because this would hold up the entire project. So in terms of critical path, we took it out of the critical path by just changing the design slightly on the side here. The third mezzanine area, which was indicated in the original plan, in the educational building, this is the 9-foot one wall. These would have to have been built and floored here because the truss design were half trusses, so they would come from the outside edge and rest here, and it would form a room up here. So that meant you had to build these walls and floor it before you could actually set trusses. So again, in terms of critical path, it would come up there pretty high in that. There's one other area, but let's just go ahead and mention what happened here in this is that the truss changed, and it went to a full truss, expand the entire educational area, and it framed out the mezzanine type area, giving it a floor and everything. So it still had the two walls underneath, you can see indicated here, 2x6 walls, but the actual load technically would be borne by the truss here. I'm sure they'd share the load there with that, but in terms of the order of build, if you had the exterior walls, then they could set the trusses, and these interior some walls here making the hallway. They could be added anytime, and then the flooring could happen later. So it goes out of the critical path because of the change in truss design. So that puts us back to just the floor behind the stage here, which all went up rather quickly and enabled these upper walls to be built before the truss team arrived. So there's one other area in the critical path, though, that presented a problem here and had to be dealt with early on. This area down in here actually has double walls with a 1-inch gap. It's firewall here. And if you think about what has to take place first here, since we have sheetrock facing sheetrock, in a typical design where you built the wall on the slab and then tilted it up, you would have to work from the inside out here. And which would necessitate building these interior walls here. Well, they wouldn't have to do those, but these are firewalls here, 2x6. You would need those because, again, you have sheetrock facing sheetrock with a 1-inch gap. So the reason this gets into the critical path is this outside wall here, indicated in blue, is actually a load-bearing wall of 20 feet 4 inches. So again, thinking about tilting them up, this wall here would probably be the last one to go up because you can't, this has to be sheetrocked and stood up, and then this one's sheetrocked, actually sheathed with plywood since it's a shear wall, then sheetrocked and then stood up. Well, that would necessitate closing this in, and so if you think about the order of things, pretty much you'd need to do these 2x6 walls. These could be done later inside, but you'd have to stand up this wall here, which is a 2x8 wall, and then has sheetrock on it, and then this outside wall in terms of the order of things. So you have to get started pretty early here in order to get this wall up in time for the truss to carry the weight as they are installed. As it turns out, and we'll deal with this a little more later, these walls are actually built out on the parking lot and then flown in by the crane. And so the actual order is not as critical there because they can be dropped in and placed. So, but in terms of deciding what to do first ahead of time, you don't necessarily know that you're not going to have a slab. And so this was in the original critical path plan. It had two main areas, the back area with the stage and mezzanine, and this area, which means they had to be dealt with quickly. So much for critical path.